Hey guys, this is part 2 of our exponents and multiplying polynomials lesson. Today we're going to look at multiplying our polynomials. Our first examples are going to be monomials multiplied by binomials. Just to recap, a polynomial is a string of terms that are added or subtracted. If there's one term, we call it a monomial. Two terms is a binomial. Three terms is a trinomial. Anything more than that, we just call polynomial, okay? So in example 17 here, we have a monomial, this 8a squared, multiplied by the binomial 4a minus 8. So whenever we multiply a monomial times a binomial, trinomial, any number of terms inside there, you're simply going to distribute that monomial to each term and multiply. So that's why I have these little arrows here, or kind of little rainbow looking things. We're multiplying 8a squared by 4a. Next, we're going to multiply 8a squared by negative 8. So here we go. 8a squared times 4a, we simply multiply 8 times 4 is 32. A squared times a is a cubed. Remember that if there is no exponent, it is an understood 1. And when you're multiplying powers with the same base, such as a squared and a, you add your exponent. So a squared times a is a cubed. Next, we're doing 8a squared times negative 8. 8 times negative 8 is negative 64. A squared. The negative 8 doesn't have a variable, so the a squared doesn't change. These are not like terms because this is a cubed, this one is squared, therefore we can't add or subtract them. We can't actually combine them. So we're left with 32a cubed minus 64a squared. Let me know if you have any questions about that problem. Here, number 24, we have a monomial times a trinomial. Okay, we're going to jump right in. So we're going to distribute that 7n to each of those three terms. So 7n times 4n squared, 7n times 7n, and then 7n times 1. Now we simplify. 7n times 4n squared gives us 28n cubed. 7n times 7n is 49n squared. And then finally 7n times 1 is just 7n. We have a cubed, squared, and to the first. They are not like terms, therefore, that is as simple as it gets. Next, we're moving on to what we call multiplying two binomials. So each set here is in parentheses, and they both have two terms, therefore they are both binomials. Whenever you're multiplying two binomials, there is an acronym that we like to use called FOIL, F-O-I-L. Okay? FOIL stands for firsts, outers, inners, and lasts. That refers to which terms you are multiplying. We're going to multiply the first terms in each set, then the outer terms, then the inner terms, and then the lasts. Okay? So, again, I like to draw these little arrows to show what we're doing. Okay, so first we'll do our firsts, the first term of each set of parentheses, so 4x times 2x. Then our outers, so that would be the 4x and the negative 1. 4x times negative 1. All right. Next we have our inners, so negative 3 times 2x. And then finally our last, so the last of each set of parentheses, negative 3 times negative 1. Okay, so now we simplify each of those. 8x squared, negative 4x, negative 6x, and then negative times negative becomes positive 3. Okay, but in this case we have one more step because see these middle terms here, negative 4x minus 6x. Those are like terms because they're both an x to the first power term. So we can combine those. Negative 4x minus 6x or you could think of it as negative 4x plus negative 6x. Same sign, so we add and keep the sign. That gives us negative 10x. So our final answer, 8x squared minus 10x plus 3. Let's do one more example of FOIL. We have another binomial times binomial. So we will start with our firsts. 3k times 3k makes 9k squared. Now our outers, 3k times negative 2, that makes negative 6k. Now our inners, 1 times 3k is 3k. And our lasts, 1 times negative 2 is negative 2. Again, we have these like terms here. So negative 6k plus 3k, opposite sign, so subtract and take the sign of the larger. So that makes negative 3k. The 9k squared and negative 2 just comes down. So our final answer is 9k squared minus 3k minus 2. Again, send me a message on Google Classroom or email me if you have questions about that type of problem. Our final type of problem we're going to work is a binomial times a trinomial. Okay? Here, FOIL doesn't actually work. It's still kind of the same process, but it's better if we just think of it as we are distributing. Okay? So we're going to distribute the 7n times every term in this second set of parentheses. Then we'll do the same thing with the negative 6. We'll distribute it to each of those terms. Okay? Now pay attention to how I have set this up. I've intentionally lined them up one over the top of the other in order to align our like terms so that when we're adding at the end or combining our like terms, it's easier on us. So here we go. We're going to start with distributing the 7n times everything in the second set of parentheses. 7n times 8n squared. That makes 56n cubed. Next, 7n times 4n. That makes 28n squared. Then 7n times 6 is 42n. So we're finished with distributing the 7n. Now we'll do the same thing with the negative 6. But when we write these terms, it's easiest if instead of continuing this long string, if we start lining it up underneath the terms that we're eventually going to combine it with anyway. So negative 6 times 8n squared makes negative 48n squared. So we're going to write that right here under the 28n squared because those are like terms. Now we have them lined up, ready to combine. Next, negative 6 times 4n makes negative 24n. Again, we line it up with the other n term. And then finally, negative 6 times positive 6 is negative 36. There is no other constant to combine this with, so we just put it at the end. Now, you draw your line. We're going to add it. There is no other n cubed, so that just comes down. Like terms here. So different signs, so we subtract, take the sign of the larger. Same thing here, opposite sign, subtract, take the sign of the larger. And this is the only negative 36, so it just comes down. We got a cubed, a squared, a first, and a constant. Nothing else to combine, so we are done. So that is multiplying a binomial times a trinomial. And I believe that was the last of our examples. You have the answers to your worksheet, but I do want to see your work. Okay, so this is what I want to see. Whether you do it on the worksheet that you've printed off or if you do it on your own paper, write down the number, the problem, and show your work, circle your answer. Message me if you have any questions, and have fun with your math.